Can you hear me? Can you hear me? All right. Welcome to K-pop course called General Physics 1. So, let me explain briefly what we study this semester. I already know that there are so many students came from not science or engineering major. So I'm happy to study physics with you. So before I begin, let me introduce our K-pop digital library. Oh, wait a second. Okay, this is K-pop digital library. Here, the kpope.org, you can find all of the educational materials that we deal with in this semester. So if you scroll down, you will find the table of contents. We are studying General Physics 1, that is Series X. If you click Series X, then you come here. And this is a Series X, and Series Y is General Physics 2. Our textbook is just the first one that begins with X1 and it ends up with X28. And in this library, there are so many links, and basically, this is the textbook. And this textbook includes the links to the YouTube lecture. If you prefer Korean, then click this to watch the lecture regarding X1.
매일 생활하는 그런 영역에서는 여전히 잘 맞고 양대역학을 써야.
If you prefer English,
Hi everybody. Welcome to K-pop guide for General Physics 1. Cool.
okay. And the content. So before you come to the class, you had better read through the PDF file, and if you need some explanation, then you can click whatever you want to watch the explanation. And if you have enough time, then there are a lot of exemplary problems and their explanation. So in this case, the checkpoint, I asked to find a false statement, but I have corrected everything and there is no loophole and everything is correct. Even if it reads find a false statement, there is no false statement. Everything is correct. So just for training, just read it through the exemplary problems. And if you need some explanation, you can also click this to find.
세션이 녹화되고 있습니다. 이걸 녹화를.
Okay. All right. And furthermore, we have additional sample problem. All right. And it's not too long. And you'll find there's a big difference between the mathematics textbook and it looks at first glance I used a lot of math, but I don't bring anything from anywhere. Just everything is inclusively included in the K-pop text. That's the strong point. If you stay on here, you will find in a few weeks it will be very comfortable to study, to go ahead with the physics contents. And again, especially physics 1, I provide you with both Korean and English version of the text. Text is only English, but explanation is given in both Korean and English. So every class you study this X1, then you take the beta exam for X1, that is a beta 1. So we have 28 betas to complete the course. But there are so many students who want to study further in the weekend, so I have prepared an additional problem set that is called the Joker. So every weekend from beta 1 to beta 7, we begin with the Joker from September 27th. After that, every weekend from Friday 9 a.m. through Sunday 11 p.m., we are able to take a double beta test that is called the Joker. Okay? So during this semester, you can solve 530 problems. Okay? And in each beta exam, you are free to take the exam repeatedly by 5 times at most. Okay, so you can enhance or correct your answer sheet by 5 times. Okay? And the contents of what we study is basically classical mechanics. So classical mechanics, introduction, the physical dimensions and mathematical dimensions are completely different. And in mathematics, we do not have the mathematics teachers do not teach you physical dimensions, and only mathematical dimensions you learn. You have to distinguish it from the mathematical dimensions. In physics, we have both the physical dimensions and mathematical dimensions. And then we describe the motion. These are based on the Galileo's kinematics. And as soon as Galileo introduced the inertial frame of reference, the explicit mathematical object to describe the frame of reference was introduced by René Descartes. That is called the Cartesian coordinate system you are familiar with from elementary school. For example, number line, xy plane, and xyz space, something like that. So beginning point of the physics is to describe the motion of an object, and that happens in 3 dimensions, especially the 3-dimensional Euclidean space. So we have to learn what a simple vector, the most elementary vector, is called the displacement. From displacement, the time rate of changing displacement is called velocity, and time rate of changing velocity is called acceleration. And they are all called kinematics, the description of motion. And then we study dynamics. Dynamics means that we want to learn why such kind of motion happen that was first introduced by Newton, that is called Newton's equation of motion, that is based on the three laws of motion. That is the first law, the law of inertia, introduced first by Galileo Galilei, and Newton's second and third law was able to break the dark age to open a new era. So that is called the classical mechanics changed the world history. We will apply Newton's laws of motion to describe the specific phenomenological motions based on the friction and tension, something like that. Unfortunately, Newton did not know the concept of energy, as well as René Descartes. The first one who understood the concept of energy was Leibniz. And Leibniz, although he missed the over factor 1/2 in the kinetic energy, so he was the first one to understand the energy concept of energy. And after that, after the introduction of Newton's Principia, it took almost 100 years to understand the concept of energy. And then Industrial Revolution appears after that. And energy conservation, as well as the linear momentum conservation, basically coming from the Newton's third law, is a quite important conservative mechanism. And if you know the conservation, you don't have to compute the same thing repeatedly, and you just keep the number in advance and use that same number without further calculation. So the concept of energy conservation, linear momentum conservation, such kind of conservation law is a very, very practically useful one. And then, until high school, even if you learn physics in high school, this concept of center of mass, you learn not in high school, but in the elementary school. It is ridiculous, but anyway, we study the center of mass of a system of particles. The basic concept of a particle nature of motion is extended to the bulk object, and especially for the strict one, such as a rigid body, whose relative position of any two parts is constant. All right, so when we consider a system of particles, for example, we can consider the collision of two billiard balls, something like that. So a system of particle treatment for the motion, equation of motion, involves the rigid body motion. And in that we study a linear momentum conservation and angular momentum conservation in a rigid body under free space. In free space, that means no external force or no external torque is applied. In that case, the linear momentum and angular momentum conservation is also valid. So based on this idea, we extend that one to study the rigid body dynamics. The motion of a bulk object is in some sense, quite similar to the motion of a particle, but it has a special feature. So that's the most difficult one in comparison with what we learned in high school physics. And we study some fluid statics. This is Archimedes' principle, for example. And then we study fluid dynamics, summarized by the Bernoulli principle. And we study a very simple dynamical system called the harmonic oscillator. Harmonic oscillator is a mass attached to a spring. And we experience a lot. And every clock uses a harmonic oscillator. So there is a so many applications of harmonic oscillator. But in nature, the damping is always present. So we have to, if I write a swing, that it stops in the end. So if you want to keep swinging, then we have to supply some energy that is to avoid damping. That is called driven damped harmonic oscillator. It is a very important, especially for any electronic devices uses this driven damped harmonic oscillator. So this is a fundamental classical mechanics applications. And then we study Newton's universal gravitation. And it is the most important primitive success of calculus. And you know the calculus was not developed by mathematicians, and the calculus was developed by physicists called Newton and Leibniz independently. And then we study wave. Wave can be treated as a system of particles. That means that many harmonic oscillator combination can reproduce the motion of a wave. So that is a classical, the extremely difficult one in this limit. And if you take the course with the intellectual beauty hiding in physics, we at the end of the semester we deal with this the wave equation in a very simple way, and that are already given in the Exercise 21, 22 of this General Physics 1 course. And it is very in detail. We will study this part, X21 and 22, in the Intellectual Beauty series. Finally, at the end of the semester, we study thermodynamics. Thermodynamics, first law, second law, kinetic energy of ideal gas, Maxwell-Boltzmann distribution, and all of this information is very fundamental for the building block of chemistry and even biology. Finally, the entropy, and second law of thermodynamics that we study at the end of the semester. Okay. I believe many of you have already taken at least a single K-pop course. For example, from Galileo to Einstein, or Escape from Scientific Absurdity. So I expect many of you are familiar with the evaluation system of K-pop. And I have described almost everything in the Neighbor Cafe already and announced it through the blackboard. So if you have any question, then please write your question on the board. K-pop Neighbor Cafe Q&A/P2. I think I have explained almost everything, and if you have any questions, please visit to K-pop Neighbor Cafe Q&A/P2 and look around what is already written there, and look over the questions raised by many other students. Okay. Thank you very much for joining us, and I hope every one of you stay in the class until the end of semester and be happy with me. Okay, thank you so much.